I'm going to talk a little bit about polyatomic ions. So that's a kind of a big word. And what it means is you have something that has a charge, and that thing is made up of more than one atom. So instead of just saying oxygen has a -2 charge, we might say sulfate has a -2 charge, where you have sulfur and oxygen together. Okay, so a polyatomic ion is a group of atoms with an overall charge. It's kind of like a molecule, but it has a charge, basically. And so we have this list of polyatomic ions. This is in your book. And does anyone see any kind of trends on this list? Okay, so hydrogen, we see hydrogen show up. Sometimes we see a lot of oxygen showing up. What kind of charges are we seeing here? They are mostly negative charges. Okay, most of the polyatomic ions will have a negative charge. There is one exception. It's at the bottom of this chart. It's ammonium has a positive charge. The rest have negative charges. One thing that's very important with the polyatomic ions is the last three letters. The last three letters. The last three letters determine what that ion is. So if you look at some examples here, we have, I'm going to look at these two. We have nitrate and we have nitrite. And they're different things. And the only difference is one vowel. Is it an A or is it an I? So nitrate is different than nitrite. The difference is the number of oxygens. So nitrate is NO3 with a -1 charge. Nitrite is NO2 with a -1 charge. And if we look through this list, we'll see a similar kind of trend showing up throughout the list, where you have something with an ATE ending has one more oxygen than something with an ITE ending. So we have chlorate and chlorite, sulfate, sulfite. We have a lot of these showing up, phosphate and phosphite. Or we don't, I guess we don't have the phosphite on here. So we have a lot of these similarities showing up. So make sure you get the ending right when you are writing down the name of a polyatomic ion. Also with the polyatomic ions, they're all on this table. What that means is don't just make them up. Don't try to make up a new name. If it looks unfamiliar, try to find it on the table and see which one it is. So don't try to make up a new name for something. What do you need to know about this table? You will usually you'll have access to this. I'm not going to expect you to memorize the table. But what you do need to do is you do need to be able to look at what's on the table, and from that correctly use it to make a compound as necessary. Okay, and we'll get some practice with that today, and also in lab next week. Okay, so how do we name an ionic compound? Ionic compounds will fall into two categories. And those two categories, I guess we could make more categories, but we're going to talk about basically two categories here. The two categories are metals that form only one type of ion, and metals that can form more than one type of ion. Okay, so we'll talk about the first type there first. So metals that form only one type of ion. What this means, when we looked at that periodic table earlier, these were the metals on that periodic table where it showed what the charge was for those metals. That is the only type of ion that those metals can form. So let's see if we have that. Let's go back to that list again. Okay, so these metals. So the metals that are shown on this periodic table are in that group 1 of metals that form only one charge. There's only one thing that they can do. Lithium can only be +1. Calcium can only be +2. Anything on this what we're showing here can only have that particular charge. So those are the kind of the type 1 metals. So let's go back to where we were. Yeah, so group 1A and group 2A and group 3A. And group 3A is basically aluminum and the couple of elements below it. They will always be +1, +2, and +3. Okay, so those are metals that form only one type of ion. Okay, so we're showing here that in this slide as the fixed charge metals. So groups 1, 2, and this 13. So this, I'm using the other numbering system here for the periodic table, but the same idea, 1A, 2A, 3A. There are a few exceptions. You don't have to remember these exceptions, but they will show up in the lab next week. So silver and zinc are exceptions, and we'll talk about those during lab next week. So we have the fixed charge metals, and then we have the variable charge metals. The variable charge metals are basically any other metal. These are the transition metals. These would also be metals in group 14 or 15 that maybe they're below the nonmetals. These are also variable charge metals. And what I mean by variable charge is that depending on the situation, they could have different charges. So you could have iron as a +2, or you could have iron as a +3. You could have manganese as a +1, +2, +3, +4, +5, or +7. Some of them can have lots of possibilities. So you don't know what its charge is going to be unless you are somehow saying what that charge is. So for those variable charge metals, what we do is we use a Roman numeral to show what the charge is in that particular case. Okay, so the charge can vary. We need to indicate what it is in any given situation. For the metals with a fixed charge, we don't do that. Lithium is always +1, so we don't say lithium 1. It's always +1. Okay, it would be wrong to include that. If it's one of the other metals, we do include that. So we need to know if it is one of those metals, we need to know to include that.